All right, we are on day 3. We have some important vocabulary again. We're going to talk about the word subset. A subset is a part of a set. There's some different symbols that we can use. It looks like a little squished C with an underline. Okay, that's the symbol for subset. If there's a slash through it, it means it's not a subset. So given that we have this set A and 1, 2, 3, 4, 5, B is 2 and 4. 2 and 4 are part of A, so B is a subset of A, which you would write with the notation B and then that symbol A. The empty set is a subset of every set. When we talk about empty set, you can write empty set as braces that have nothing in it, or you can write empty set like this, like a 0 with a slash through it. It says the possible number of subsets equals 2 to the n, where n is the number of elements in a set. So for this subset, there's 5 elements, so we would say 2 to the 5th, so we would have 32. Number 1, example 1, says determine if A is a subset of B. So is A a subset of B? So A, B, C. A, B, C. They're all in B, so A is a subset of B. 3 and 9, and in this set we have 3 and 9, so A is a subset of B. And then C, 3, 9, and 12, we have 3, 9, but we don't have 12, so A is not a subset of B. Okay, and then proper subset is the next vocabulary word. It says subsets that are not the exact same. So A, 1, 2, 3, 4, 5, and B, 1, 2, 3, 4, 5 are subsets, but they're not proper subsets because they are exactly the same. The complement of a set, we have a few different notations. We have A with what looks like C as the exponent, A with what looks like a negative sign as an exponent, and A with what is an apostrophe. We call that a prime symbol. Okay, that symbol we call prime. So you might hear it read A prime. The set of elements in the universal set that are not in A. So the universe must be specified in order to compute the complement. So the universal set is 1, 2, 3, 4, 5. H is 3 and 4. Then the complement of H would be everything that's in the universal that's not in H. So 1, 2, and 5. Okay, example 2. Given set D and subsets H and S, answer the following. So in this situation, this is considered our universal set, and these are our subsets. Are H and S proper subsets? Why or why not? So if we go back to our definition up here, subsets that are not the exact same. So let's just double check and make sure they're subsets first. So H has 2, 7, 9, and 11. 2, 7, 9, and 11 are in the universal set, and 2, 7, 9, and 14 they are in the universal set. They are not exactly the same, so they are proper subsets. So we would say H and S are proper subsets because they are not exactly the same. What is the complement of H? So again, we can use any notation. We can use the little c, the negative sign, or the prime symbol. So the complement of H is going to be everything that's in D that's not in H. So 4 would be our first one. 5 would be our second one. 7 and 9 are both in H. 11 is in H. And then we'd have 14. So that is our complement of H. A power set. This is our last big vocabulary word for this section. It says it's a list of all subsets including the empty set. So if I had the set 1, 2, 3, I always start with the empty set so I don't forget it. So the empty set is one set. Each number listed individually is a subset, and then you can go for the pairs that you'd have. 1 and 2, 2 and 3, 1 and 3, and then the set is actually a subset of itself. So remember that rule that we talked about? We had 2 to the n. how many elements are in here. So this would be 2 to the third, which is 8. So I have 1, 2, 3, 4, 5, 6, 7, 8. There's 8 subsets. So that's a way you can check to make sure you didn't forget to include any. And then you want to make sure you don't repeat. So don't repeat would mean, like, if I listed 3, 2, that's the same thing as 2, 3. So I don't want to repeat it. All right, so example 3, it says, let set A be A and B. How many distinct subsets will there be for set A? So we can use our rule that we talked about. It would be 2 times 2 to the second, so there should be 4. So if I wanted to list them out, we'd have, you could say the empty set, right? We can say just A. We can say, just B. And this set is always a subset of itself, so AB. So 1, 2, 3, 4. What is the power set of A? And, oh, sorry, I was supposed to write that there. So the power set of A would just be listing out all of our sets.